Hello, today I am going to show you how to custom machine a Vespa crankshaft if you're going to make your Vespa electric, like I am. So, here's what we're doing. So our original crankshaft, which is right here at the moment, is in a very sorry state. So is the jug and the piston. The head was fine, and that was the only thing savable from the whole thing. This will not work with these because I bought bearings that were slightly too wide. See, what I'm trying to do, I'm trying to convert my Vespa 160 that I bought a couple weeks ago to electric, so I can drive it on the road without registration or insurance. So, I have this crankshaft here, and even if I did convert this to electric, you notice these giant weights on the bottom? They're meant to counteract the piston moving around. If I just put this in, it would vibrate really badly. So, we're making a new crankshaft. So what we need is the measurement of this right here, because I'm planning on using the original clutch, which is back here. I'm planning on using this original clutch. How to do this is I'm going to have the clutch and everything on one side. Sorry about the device getting in the way. Clutch and everything on one side, and on the other side, we just have a shaft with either a gear, not a gear, a sprocket, or a pulley on it. I haven't figured out which one yet. I think I'm going to go with a sprocket, but either a sprocket or a pulley on it, so that's what I'm going to do. This one has got the tapered ends, and of course the ends are mushroomed, so I can't really use it anyway. At any rate, we need to make a crankshaft, and that's what we're going to do today. So, I have this piece of aluminum, which I have machined down to fit onto this bearing. It is a press fit, but it does fit. It is a press fit, though. Ow, that's still really hot. So what we need to do, we need to measure this out. And we need to do it exactly how this does, because we need this angled shaft, whatever it's called. We need the shaft to work properly, so it can accept the clutch. So, let's fix that. Let's work on that. Okay, so here is my drawing of what I need to do. Okay, so first cut we're going to take is going to be 551 thousandths of an inch in this way for the threaded section for the nut for the clutch. Okay, with that done, we're going to go on to the next section, which is this shaft right here. Now, as we can see, this shaft is at a taper. So what I'm going to do, I'm going to machine the part down to 0.72 or 720 thousandths of an inch, and go from there. Once I get it to there, I will set the angle on this using this thing, and what I'll do is I'll turn that. So the angle from 0.72 will coincide with the end of this. It will end there. And that's how I'm going to do that. Because if it's not right, then it won't match. So that's how we're going to do it. Okay, that one I'm not proud of the finish on, but it did come out. So now we have to taper this shaft down to there. Okay, there we are. Now that is at a slight taper. And if I grab the clutch, we can see that if I bolt it on there, it does fit in pretty well. That's actually locked in place. But I'm still going to have to mill a keyway into it for the keyway. But yeah, that's pretty good. Let's do that. Okay, our next measurement is 3/4 of an inch. And it is 0.72 inches long. Or what is it? Is it? No, it's 0.785 inches wide. So it's this thing right here. Okay, there it is. That's the new piece. As we can see, it is wider by about 10 thousandths. Alright. Now, we do nothing for, I think it's 2 1/2 inches. And then, the last 2.3 inches of it are going to be 7.85 the width. So, and then our crankshaft will be basically done. I will throw it after it's all done machining on there. I'm going to throw it on the mill, machine a keyway because the clutch is held on with a key. machine a keyway, and then tap use the die, which is a 1/2 inch 20 threads per inch die, to tap right here to put a nut on so we can lock the clutch in place. And then our crankshaft will be done. Okay, here we have the lathe down crankshaft. I didn't put this at 745 or what was it? Yeah, 785, because I'm gonna put this sprocket on the end, and it's gonna be bolted on like that. So I'm gonna have to drill a hole in it and thread that too. But I have this in this what is this condition here? It's pretty good. So now we're gonna throw it into that mill right there. It is, what kind of mill is this? Clothing mill, and we're going to cut a keyway into that portion. Well, there's the keyway I did. It's the best I could do with the tools I had at my disposal. Now I am threading the end with a die. Those, I say, came out really well. If I can shut the flash off for you really quick. Those came out really nice. Man, it's looking for something to focus on too. And we finish all of it off by tapping the inside 7/16 20. And that's our crankshaft. So we did have a little bit of issue on here because it would grab and pull. But overall, I think it came out really nice. Compared to the old one especially. Where's the old one even? Right there. Compared to that one, this thing is going to work really well. So that is how to easily, or relatively easily, make a replacement crankshaft. Make a replacement crankshaft for your large frame Vespa if you would decide to convert it to electric using a starter motor.